Hello everyone. I hope you're all doing well. Today we're going to work on 4.2. Our essential question is how can factors be determined from a polynomial? We're going to learn how to factor a polynomial today basically. First of all, let's see what is factoring. Factoring is finding what to multiply together to get an expression. Factoring is actually opposite of multiplying. For multiplying, we get two or more things and we multiply them together and we get an expression. For factoring, we have that expression and we want to find those things, like maybe two or more than two things that we need to multiply to get that expression. Okay, so first let's practice a little bit more about multiplying, which we have learned before. We have 2x minus 3 times x plus 4. To get the answer of this multiplication, I can start multiplying by getting the first term here. Okay, so by getting the first term here and multiply that by the two terms that I have in the second parenthesis, by these two. So 2x times x is 2x squared. 2x times 4 is 8x. Negative 3 times x is negative 3x, and negative 3 times 4 is a negative 12. Negative 12. Then I need to simplify this. 2x squared is alone, so I can just write it down here. Then, do I have any other like terms here? Yes, 8x and negative 3x are like terms, so I can combine them. 8 and negative 3 is 5. So this will be positive 5x. And then negative 12 is alone here, so I'm just going to write negative 12. So that's how I multiply them. Now I'm going to learn how I can go backward and find the factors if I already have this expression. So we're going to learn how to factor trinomials basically here in this lesson. We're focusing on trinomials, the algebraic expressions that have three terms. The first step is to find a GCF. Do we have any GCF or not? Let's see. We have 2x squared, 5x, and negative 12. Well, do we have any common factor between these three? No, because this one is 2 and 12. They both are divisible by 2, but 5 is not divisible by 2. So looking at the coefficients, there is no common factor. And also looking at the variables or the letters that we have here, x squared, x, and this one doesn't have anything. So there's nothing in common between them. So in this case, there is no GCF. After that, I need to find A, B, and C from this trinomial and then use the big X. Let's see what does that mean. Use the big X. What is A, B, and C? We're going to use the standard form of trinomial, which is ax squared plus plus bx plus c. So we're going to find the correspondent coefficients and get our a, b, and c. So the coefficient of x squared is a. So a is 2 here. Coefficient of x is b. That's 5. And then the last one, which is the constant number, is the c value, and it's negative 12. I found my a, b, and c. Now I'm going to use the big X. So use a big X here. On top of this big X goes a times c. What is a times c? 2 times negative 12, which is negative 24. On the bottom of this big X goes b, and that's 5. Now I need to find two numbers that if I multiply them, I get negative 24, and if I add them, I get 5. What are those two numbers? Sometimes it's easy to do this operation in your head, but sometimes it's a little bit hard, so we can use our calculator. So I'm going to use my calculator this time to let you know how we can find that using our calculator. So you can go to y equal to, and here write the a times c, which is negative 24 here, divided by x. Okay, so that's what you need to do. And then you go second table, and this is going to give you all the factors of negative 24. Okay, so let's see what numbers could give us negative 24. Negative 1 times 24 will be negative 24. But if I add them, do I get 5? No. Next one is error. Next one is 1 times negative 24. Again, they multiply to negative 24, but don't add up to 5. 2 and negative 12. Add up to 5? No. 3 and negative 8. Add up to 5? No, they don't. But so if I just continue going forward, 4 and negative 6, again, don't add up to 5. And the next one is just a decimal number. I don't count the decimal numbers, okay? So just ignore the decimal. Then 6 and negative 4, do they add up to 5? No. Next one, decimal, ignore that. The last one here is 8 and negative 3. Do they add up by 5? Yes. 8 and negative 3 is equal to 5. So I can write those numbers here, 8 and negative 3. So once I get those two numbers, I'm going to go to the next step. Split the middle. What does that mean? I'm going to write the term here again, to the expression here, 2x squared plus 5x minus 12. Keep the first term as it is here. Split the middle term using these two. 5x is 8x minus 3x. So you split the middle one and then keep the last one as well. This was the third step. Now the fourth step. Use the four-term grouping into groups. So I'm going to put these in groups. First group and this one, second group. Then we need to find the GCF of each group. What is the GCF between 2x squared and 8x? I'm going to write that here, 2x squared and 8x. What is in common between them? Between 8 and 2, 2 is in the common factor. The greatest common factor between 8 and 2 is 2, because 8 is divisible by 2. So I can just take the 2, and then between x squared and x, again, the smallest one is the common factor, the greatest common factor, because x squared is divided by x. So if they are divisible by each other, you can just take the smallest one as the greatest common factor. So 2x is the common factor between 2x squared and 8x. Now, I need to factor 2x out of these two. If I factor 2x out of 2x squared, I need to divide 2x squared by 2x. 2 by 2 by 2 will go away, and x squared divided by x will be x. So all you need to do is to subtract the exponent of the top one from the exponent of the bottom one, which is 1. 2 minus 1 is 1, so that's 1. Okay, so if I factor 2x out of 2x squared, I will have x left. Now factor 2x from 8x. X and x cancel each other, and 8 divided by 2 is 4. So I'm going to write positive 4 here. Now let's factor the second group. Between negative 3x and negative 12, what is in common between them? Well, since this one doesn't have any x, so I'm just going to ignore this part, the letter part of the term, and then just pay attention to the coefficients, 3 and 12. What is in common between them? Because 12 is divisible by 3, so 3 is the GCF between these two. So I'm going to write, and because I already have a negative for both of them, I'm going to write negative 3 here. Now factor negative 3 from negative 3x. It's like you're dividing negative 3x by negative 3. Well, these two cancel each other, and I have only 1x left. Next, factor negative 3 from negative 12. That's like you're dividing negative 12 by negative 3, and it's equal to 4. So I'm going to write plus 4. Make sure you write the sign of this number here, plus 4. You don't leave it blank. You cannot just write x4. That's wrong. You need to write x plus 4. Whatever is the sign of this number, the second one, you need to write that here. Okay, so now the last step is again to factor these groups, these two groups, first group and the second group. What is in common between these two? What is the common factor between them? Well, as you see, this one is 2x times x plus 4. This one is negative 3 times x plus 4. So x plus 4 is the common factor between them. It's the greatest common factor between them. So I'm going to factor x plus 4 from both of these. If I factor x plus 4 from the first group, it's like I'm dividing this by x plus 4. So what happens? This x plus 4 will be cancelled with this x plus 4. And then I will have only 2x left. So I'm going to open my parentheses and write 2x. Then for the second group, again, if I factor that out, it's like I'm dividing negative 3 by x plus 4 by divided by x plus 4. These two cancel each other, and I will have only a negative 3 left. So I'm going to write negative 3 here. And this is the factored form of this trinomial. The method that I just taught you is called grouping. So this is the method one method that we can use to factor trinomial. There's also another way to factor trinomial, which is kind of faster and easier. So I'm going to teach you this one as well. You can choose any of them that you are more comfortable with. So to use the second way or second method, which is called slide or divide, first, once you have the trinomial, first you need to find those two numbers. Once you find those two numbers, you're going to use two parentheses here and write the letter x inside both of them. And then what you need to do here now is to bring these two numbers into the two parentheses that we have. So I'm going to write negative 3 and positive 8 here. Next, you're going to divide these two numbers by the a value, which is 2 here. So divide both of them by 2. Okay, now let's see, are they divisible or not? If they are divisible, like 8 over 2 is 4, I'm just going to write the 4. But what if they're not divisible? 3 by 2, you cannot find an integer number. The answer is a decimal number. So you're not going to divide that. And all you need to do is to slide this to the front of this x. So it's going to be 2x minus 3. So as you see, we got the same thing that we had before, but faster and easier. Now let's work on the first example, 3x squared plus 21x plus 30. We want to factor this. The first thing that we need to do is to find the GCF. Is there anything in common between these three terms? We have 3x squared, 21x, and 30. And as you see, they are all divisible. All the coefficients are divisible by 3. So I can take the 3 as the common factor between them, the greatest common factor between them. And if you look at the letters, this one is x squared, x, and this one doesn't have anything. That means between the letters, there is no common factor. So I'm just going to take the 3 as the GCF here. Now I need to factor the 3 out. So if I factor the 3, I need to divide all these terms by 3. 3x squared by 3 is x squared. 21x divided by 3 is 7x. And 30 divided by 3 is 10. Okay. Now I have a trinomial here, and I'm going to use the big X to factor that. what is my A, B, and C value? I use the standard form to find A, B, and C. So A value is 1 here because the coefficient of x squared is 1. B value is 7 and C is 10. Now I need to find two numbers that if I multiply them, I get 10, which is A times C. And if I add them, I get 7, which is the B value. So this one multiply and this one is adding them. Now I'm going to use my calculator. Okay, now I'm going to use my calculator to find those two numbers. I go to y equal to and write 10 divided by x, then use second table and look at the numbers that I have here. -1 and -10 multiply, and then the answer will be 10. But if I add them, I don't get 7. 1 and 10, no, I don't get 7. 2 and 5, yes. If I multiply them, I get 10, and if I add them, I get 7. I'm going to write 2 and 5 here. Then I'm going to use the easiest method. So use the two parentheses here, write x, and don't forget about the 3 that we already had as the first factor. And then write the two numbers here, 2 and 5. Now, what is my A value? It's 1. So I'm going to divide them by 1. Does it make any change? No. 2 divided by 1 is itself. 5 divided by 1 is also itself. So I don't even have to write that. So if it's 1, you don't need to worry about anything. And that's the factor form of my polynomial. Let's go to the next one. Y squared minus 11y plus 30. Do I have any GCF here? No, there's nothing because the coefficients are 1, 11, and 30. They don't have anything in common. And the letters y squared y and nothing, again, there is no GCF. So I'm going to use my big X here. On top goes A times C, which is 30. And on the bottom goes B, which is 11. Now I need to find two numbers that multiply by 30 and add up by 11. So use our calculator, go to the y equal to, and then here I'm going to write 30 divided by x, and go to the table. What are those two numbers? Well, you see that I have 1 and 30. Well, they don't add up to 11. 2 and 15, no. 3 and 10, no. 5 and 6, yes. They can add up to 11. So I'm going to use the 5 and 6 and write y here, then the two numbers 5 and 6. Okay, what is my A value? It's 1. So if I divide them by 1, doesn't make any change, so I don't even need to write them. And that's the factor form of my polynomial or trinomial. Example 3, 2x squared plus 7x plus 3. Do we have any GCF here? No. The coefficients 2, 7, and 3, they're all prime numbers and they don't have anything in common. The letters also x squared, x, and nothing. Well, there's no GCF here. Now use the big X. On top goes A times C, which is 6. The bottom goes B value, which is 7. What are those two numbers that if I multiply them, I get 6, and if I add them, I get 7. You can do it in your head again or use your calculator. So I'm going to write 6 divided by x here. Okay, and use the calculator. -1 and -6. If I multiply them, I get 6, but if I add them, I don't get 7. 1 and 6, yes. Multiply, get 6, and add them, you get 7. So I'm going to write 1 and 6 here, and then the parentheses here, x, then the two numbers, 1 and 6, And then what is my a value? It's 2. So I'm going to divide them by 2. If they are divisible, I'm just going to write the answer. 6 divided by 2 is 3. If they are not divisible, I'm going to slide the bottom to the front of the x. So it's 2x plus 1. Now let's work on the next one. Now, the first thing that I need to do here is to find the GCF again. What do we have in common between all these three terms? X to the 3, 2x squared, and 15x. Looking at the coefficients, there is nothing in common. 1, 2, and 15. There's nothing in common in all of them. How about the letters? I have x to the 3, x to the 2, and x. Well, the x here is in common between all of them because they're both divisible. Both of these are divisible by x. So I take the smallest one as the common factor. So that's going to be x. That's my common factor. Okay, so I'm going to write that here and try to factor x from all these three. So I need to divide all of them by x. X to the 3 divided by x will be x squared. Because all you need to do is to keep the base and subtract the powers. 3 minus 1, the power of x is 1. 3 minus 1 is 2. Next one, 2x squared divided by x will be just 2x. Again, 2 minus 1 is 1. And then the last one, negative 15x divided by x will be negative 15. Now I'm going to use my big X here. Two numbers that if I multiply them, I get A by C, which is negative 15. And if I add them, I get 2. So you multiply, get a negative 15, and add them, you get 2. Okay, so I use my calculator, y equal to negative 15 divided by x, and then go to second table. The numbers, negative 1 and 15, they don't add up to 2. 1 and negative 15, no, do not add up to 2. Next one is a decimal number, so I just ignore the decimal number. Then I have 3 and negative 5. Do they add up to 2? No, they add up to negative 2. And then the next one, 5 and this one is decimal, so I ignore that. And the next one is 5 and negative 3. Do they add up to? Yes. So I'm going to write 5 and negative 3 here. Okay, so I'm going to write the factors now. Don't forget about the first one. That's x, the first factor. And now the other factors, I'm going to write x here and the two numbers 5 and negative 3. What is my a value? It's 1. So just divided by 1 is itself. So I can stop here. And this is the factored form. Okay. Now let's go to the next one. Do we have any GCF here? 4x squared 9 minus 9x plus 2. Between the coefficients, there is nothing in common. So there's nothing. And also, if you look at the letters, again, there's nothing in common. So there is no GCF. Use the big X. Two numbers that if you multiply them, you get 8 times C, which is 4 times 2, 8. And if you add them, you get B value, which is negative 9. Multiply and add. What are those two numbers? Again, if I use my calculator, I will see that if I use negative 1 and negative 8, those two multiply by 8 and add up to negative 9. So the two numbers are negative 1 and negative 8. So I'm going to write x minus 1 and x minus 8. What is my a value? It's 4. So I'm going to divide both of these two numbers by 4. If they are divisible, I just write the answer. 8 divided by 4 is 2. So I'm going to write ax minus 2. Is 1 divisible by 4? No. So just slide it into the front of the x. So this is 4x minus 1. And that's my answer. Next one. We don't have any GCF between the letters and the coefficients. There's nothing. So just use the big X. On top goes A times C, which is 1. And the bottom goes the B value, which is 2. What are those two numbers that if I multiply, I get 1, and if I add them, get 2? Those are 1 and 1. Once again, you can use your calculator or just do it in your head. And whatever is more comfortable for you, you just do that one. Okay, so the two numbers are 1 and 1. So I'm going to write x and then plus 1 plus 1. Now, as you see, both of the factors are equal to each other. And also, I forgot about this one. The a value is 1. If I divide both of these by 1, nothing is going to change. So I don't have to write that. Okay. So this is my factor form, but because they're both the same, I can write it as x plus 1 squared. Okay, let's go to the next one. X squared minus 18x plus 81. Do I have anything in common between them? No. So on top goes a times c, which is 1 times 81, 81. The bottom goes negative 18. Now I need to find two numbers that if I multiply, I get 81. If I add them, I get negative 18. I'm going to use my calculator this time. Okay, so I need to get 81 divided by x here. Second table. Then what are those two numbers? Well, because they should add up to negative 18. There is nothing here that add up to negative 18. None of these add up to negative 18. So let's go to the top and see if there's any negative number that I can use them for negative 18. Negative 1 and negative 81, no. This one, negative 3 and 27, no. And these are all decimals, so I ignore them. And this one, negative 9 and negative 9, yes. They add up to negative 18 and multiply by 81. So I'm going to write x minus 9. Both of them are x minus 9. So this is x minus 9 squared. The next one, first of all, let's see if we can find anything in common between the terms G, C, F. Well, the letters do not have anything in common. X squared, x, and nothing. Well, that's nothing. Okay. How about the coefficients? I have 4, I have 20, and also I have 25. 4 is just 4. 20 is 4 times 5, and 25 is 5 times 5. Well, oops, I'm sorry. Okay, so, well, I look at the 4. That's in common between the first one and the second one, but I don't see that in the third one. Also 5, I have that in 25 and 20, but I don't have that here. So basically, there is no common GCF here. Now, let's go to the big X. On top goes A times C, 4 times 25, which is 100. The bottom goes negative 20. That's my B value. A, B, and C. B is 20. So two numbers that if you multiply, you get 100, and if you add them, you get 20. Okay, let's go to the calculator again. Y equal to 100 divided by x. Second table, and we need to find those two numbers. Okay, so here are the factors that we have here. For example, negative 2 and negative 50, they multiply by 100 but don't add up to 20. And then we have negative 1 and 100, negative 100, no. Then we have 1 and 100, again, no. 2 and 50 do not add up to 20. The next number is decimal, ignore that. 4 and 25 do not add up to 20. 5 and 20, no. And then we have decimal numbers, ignore them. Then we go to the next one, 10 and 10. Yes, they add up by 10 and multiply by 100. Okay, so I'm going to write the parentheses here, x, and then write the 10. Then we need to divide by the a value. Okay, so if I divide by a value, well, they are not dividable, but they are, I can simplify them. 10 divided by 2 is 5. 4 divided by 2 is 2. The same is here, 5 and 2. So it's basically can be written as x plus 5 over 2 times x plus 5 over 2. Now they are not dividable, so I'm just going to slide them to the front of x. So it's going to be 2x plus 5 and 2x plus 5. Then just write it as 2x plus 5 squared. Okay, next let's go here. Okay, this time instead of having a trinomial, we have a binomial. We have two terms here. What are those two terms? If you notice, they are both perfect squares because x squared is x times x and 25 is 5 times 5. And also I have subtraction between them. So this is a special case. We call that difference of squares. What do we do in this case? Well, as always, the first thing is to find the GCF. Do we have anything in common between them? No. This is x squared, this one 25. They don't have anything in common. So what I do here is just write the factors of each of them separately. X squared is x times x. What is 25? That's 5 times 5. But because I have a negative here, so I'm going to put the negative in front of one of these 5s, because 5 times negative 5 will be equal to negative 25. So what I do here is to take a 1 from each, like one x and one 5 here, and then I write x and positive 5, and then 1 from the others, x minus 5, and that's my answer, x plus 5 times x minus 5. Okay, let's practice this again here. 4y y squared minus 100. First of all, do we have any GCF? Yes, you can divide both of these two numbers, 104 divided by 4. 4 is the common GCF. So divide this one by 4, then I will have only y squared. Divide this one by 4. 100 divided by 4 is 25. Now I have the same thing that I had on top. So I'm just going to write the y squared as y times y, and 25 as 5 times negative 5, and then take 1 from each. Okay? And I won't forget about the 4 that I had here. Write the 4 here, then y plus 5 and y minus 5. And that's the factor form of my binomial. Let's work on this one now. 98 and 8m squared. We need to find the GCF. Is 98 divisible by 8? No, it's not divisible. You see, so if I divide 98 by 8, I will get 12.25. So that's not divisible, but they're both divisible by 2. 98 divided by 2 is 49, and 8 divided by 2 is 4. So I can factor the 2 out here. 98 divided by 2 is 49, and 8 divided by 2 is 4. Okay, Again, I have difference between squares. So I'm going to write them as this one. 49 is 7 times 7. And how about for m squared? Well, 4 is 2 by 2. And m squared is m by m. Also, because I had a negative here, I'm going to put that for one of these two. Now I can write my factor from 2 times 7 plus 2m and 7 minus 2m. And that's the factor form of my polynomial. And this was today's lesson. Make sure you take notes and practice enough to learn all this. Let me know if you have any questions. Have a good day.